Alright, so for this video, I'm going to be solving the equation 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. So, I'm going to be solving for x in this equation, as that is the only variable. And now for my solution. I'm going to start by rewriting my equation down here so I have more solving space. So my equation is 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. Now from here, I'm going to be using the property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 8 to the power of x plus 9, and I can rewrite this as 8 to the power of x times 8 to the power of 9. And this is equal to 9 to the power of x plus 8, which I can also rewrite as 9 to the power of x times 9 to the power of 8. Now from here, I'm going to divide both sides by 9 to the power of x. So then for my right hand side, these two cancel out, and I get 8 to the power of x times 8 to the power of 9 over 9 to the power of x is equal to 9 to the power of 8. Now I'm going to divide both sides by 8 to the power of 9. So then these two cancel out, and I get 8 to the power of x over 9 to the power of x is equal to 9 to the power of 8 over 8 to the power of 9. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x over 9 to the power of x is equal to log of 9 to the power of 8 over 8 to the power of 9. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 8 to the power of x over 9 to the power of x is going to equal log of 8 to the power of x minus log of 9 to the power of x. And I can use the same property of log 9 to the power of 8 over 8 to the power of 9 to make it equal to log 9 to the power of 8 minus log 8 to the power of 9. Now, another property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is the same thing as b times log a. In this case, I can use this property for all my terms over here. So to start, log 8 to the power of x, I can move this to the front, and I get x times log 8. Now I have this minus log 9 to the power of x, I can move x to the front, so I get x times log 9. And this is equal to log 9 to the power of 8. I can move 8 to the front, so I get 8 times log 9 minus log 8 to the power of 9. I can move 9 to the front, so I get 9 times log 8. Now, because both of these terms have x in them, I can simply factor out x. So I get x times log 8 minus log 9 is equal to 8 times log 9 minus 9 times log 8. Now, we obviously want to find the value of x, and the only way to do that is to get rid of this log 8 minus log 9 by dividing both sides by log 8 minus log 9. So then these two cancel out, and I get x is equal to 8 times log 9 minus 9 times log 8 over log 8 minus log 9. Now, log of 9, we can simplify this to log of 3 squared. And remember, if I have something in the form log a to the power of b, I can move b to the front. So I can move 2 to the front, and this is going to equal 2 times log 3. Now I can do the same thing for log 8. Log 8 is equal to log of 2 to the power of 3, and I can move 3 to the front, so I get this equal to 3 times log 2. So now from here, I get x is equal to 8 times 2 log 3 minus 9 times 3 log 2, and I have this all over 3 log 2 minus 2 log 3. Now 8 times 2 is 16, so I get x equals 16 times log 3 minus 27 times log 2 over 3 log 2 minus 2 log 3. And all of this is equal to 9.6548. Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000. So I get 1,000 squared plus 23 times 1,000. And now I can distribute 25, so I get 25 times 1,000 plus 25 times 23. Now 1,000 squared is equal to 1 million. So I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem.